All right, this next example that I want to do in section 3 is looking at evaluating each logarithm. So when you get a log expression, rather than just converting it into an exponential form, I want you guys to be able to evaluate this. So looking at each part of this log form and seeing what it's equal to. So first thing we have to do is let's try to turn this into exponential form. Now, obviously, we're going to be missing a part here because we don't have all three parts of our equation, but let's see what we can do as far as evaluating this. So again, what you're going to want to remember here is think about your basic equation. We've got log base b of y equals x. Now that's our general log equation, and remember what that's equivalent to. Our base stays the same, and then we just flip each variable. So this is going to become, so when we look at this first one, we've got log base 4. So this is going to turn into an equation that has a base of 4. Now we know that this number is going to go to the other side. So our equal sign is going to go here, and 64 is going to go to the other side. Now the only part that we're missing is what becomes our exponent. So we know right here that our base is 4. We don't know what our exponent is because we don't know what is on the other side of this. But we know that when we take 4 to some power, we know that's going to be equal to 64. So to evaluate this, which just means simplify, we're trying to figure out what exponent, when we have a base of 4, gives us 64 as the equivalent. So let's go ahead and think about this. What exponent of base 4 is going to give us 64 as a result? Okay, now we know when we do this, we're going to get 3 because 4 to the third power is the number that gives us 64. So when we simplify this, we would get log base 4, 64 equals 3. So that's what we're trying to do when it says evaluate. We're trying to figure out what the equivalent of this would be. So again, remember our basic log function. Remember what that's equivalent to. And just try to fill in the missing spot. So again, in this spot, we were looking to have a base of 4, figure out what exponent, when we have a base of 4, will give us 64. So let's look at this second one. We have log base 5 of 0.2. Log base 5 of 0.2. Now that can also be rewritten as log base 5. Now the fraction equivalent of 0.2 is just 1 over 5. So you can also think about this as log base 5 of 1 over 5. So think about what number, if we have log base 5, that means that our base with our exponent is going to be base 5. So we're trying to figure out what exponent with a base of 5 gives us 0.2 or 1/5. So what exponent, when we have a base of 5, is going to give us 1/5? This one should be pretty simple. So try to think about this for a second. So what exponent with a base of 5 is going to give us 1/5 as a result? So when we do that, we get -1. If we have a base of 5, the exponent of -1 is just going to give us 1 over 5, or 0.2 as a result. So what I want you guys to do now is to figure out these next two problems. So try to figure out C and D. Now remember, with C and D, just think about your log to exponent function. So log base 5 of x equals y. Try to remember how you convert that into an exponent function.